Okay, 9.7 is quadratic systems of equations. So, like the linear systems of equations where you had two lines and they intersected, it's the same thing, but now we're going to be using conic sections intersecting. So, this process is the same. Doing it algebraically is by setting so I'm going to write some steps out. The first thing is you want to, I'm just going to put this over here, set both equations equal to y or y squared, depending on it. And I'll show you which ones you need to do y for, which ones you need to do y squared for. Step number 2 is you set equal to each other. So if I look at number 1, I have y equals x squared plus 3 and y equals 3x plus 1. What I normally like to do is label like what type of conic it is or what the equation is. So if I look at the top equation, what type of shape would that be?
A parabola.
A parabola. And then y equals 3x plus 1, what is that going to be? A line. So imagine having a parabola and a line intersecting each other. If you want, you can graph these and you can solve that way, but on a test I would have you show it algebraically. So if you want to graph them in your calculator, that's fine, and you can find the intersection points, but I'm going to ask you to do it algebraically. So I could put this on a calculator part and you could even check your answers, but I'm going to have you show it algebraically. So both of them already are y equals, so now I'm going to set them equal to each other. So x squared plus 3 equals 3x plus 1. So that's step number 2.
I can already see where this is going.
Then,
Where's it going?
step number 3, I'm going to simplify to equal 0. So basically I'm going to move everything to one side and I'm going to get equal to 0.
You got it.
So I'm going to move the 3x over, I'm going to move the 1 over.
What?
So that gives me x squared minus 3x plus 2 equals 0.
I read it out, it works.
Sorry.
Then I'm going to solve it. So step number 4, I'm going to solve the quadratic equation. You don't have to complete the square, you can just factor it.
I don't know, like those excess and y.
Yeah. So if I were to factor this, what would that look like? X minus 2, x minus 1 equals 0. And if I were to solve it, then I get two solutions, x equals 2 and x equals 1. But I want my answers to be in ordered pairs, so I'm going to have two solutions, but they're ordered pairs. So I have the two x values. Now I need to solve the y values. So last step is plug x's back into original equation, and it doesn't matter which one. In this case, the line would be easier to plug back into because there aren't x squareds and things like that. And to find y, so x, y is an answer. So your ordered pair is the final answer. So if I plug in 2 into the 3x plus 1, you would end up getting 3 times 2 plus 1, which is 7. And then 3 times 1 plus 1 would be, 3 plus 1 is 4. So my final answer would be 2, 7, and 1, 4. So number 3, I have two systems. If I want to set them equal to y equals, the top one is already done for me. I want to change the other one around to be y equals. So I could move the y to the right, move everything else to the left. You end up getting y equals x squared plus 7x plus 12. So here are my two equations. What are the types of conics? So is it a line, parabola, ellipse? What are both of them?
They're both parabolas.
They're both parabolas. And I just write it to the side. I'm not going to make you write it to the side, but it helps me envision what it's going to look like. You could type them into Desmos and see where they intersect. And for your homework, I would suggest that you do that so that you're kind of on the right track. You could put them both in your calculator. But for this purpose, what I want to do is I want to set them equal to each other. So I have negative x squared minus x plus 12 equals x squared plus 7x plus 12. Then I get everything on one side. I want to have a positive x squared, so I'm going to move the stuff on the left to the right. So I would have 2x squared, because I'm moving this over, plus 8x.
Plus 1.
And then plus 0, so I'm just going to, that goes away, they cancel, equals 0. Then how would I solve something like this? I need to take out a greatest common factor, which would be what? 2x. Then I'm left with what? When you do something like this and you just pull out a greatest common factor and you don't factor, how do I get to solutions? What do I do now?
Don't you set x equals 0?
Right, so I say that, I say 2x equals 0, and then I say x plus 4 equals 0. So I set this stuff outside of the parentheses, equal to 0, and the stuff in parentheses. So I end up getting x equals 0, and x equals negative 4. So now I want to plug them back in. It really doesn't matter which one. I'm going to just say the top one because it looks easier. So 0 minus 0 plus 12 equals 12. So I have 0 comma 12. And then negative 4 squared minus a negative 4 plus 12. Oh gosh, that may not have been an easier one. Okay.
Wait, just try it. I don't know how to do it.
Negative 16 plus 4 plus 12. That ends up getting me 0.
Okay, so whenever you do, whenever you plug it into x squared, whenever you do negative 4 squared first, and then you have negative. So it'll just go up.
Because there's a negative out in front, so.
Oh.
Okay, we're going to do number 5 and 6, and then I'm going to continue with 7 and 8 next class. So number 5, you'll notice that they both have y squareds. Okay, so since they both have y squareds, I'm just going to solve for y squared instead. So if you have a y squared on the front, you know how I said solve for y or solve for y squared? I'm just going to solve for y squared and then substitute. Okay, because if you have 2 y squareds, then you can substitute. It doesn't make sense to square root because then you get really messy stuff. So I'm just going to solve for y squared. So in the top, if I want to solve for y squared, I get 64y squared equals negative x squared plus 64. Then I divide by 64. So you end up getting y squared equals negative x squared over 64 plus 1, because that will cancel. And then the second equation, I just need to move the x squared over. So that becomes y squared equals negative x squared plus 64.
What kind of line is that?
So the first one, if you were to graph this, would end up being, well, so I look at the numbers in front of the x and the y squared. Are they the same or different? The top one. They're different because I have a 1 and I have a 64, but are they the same sign?
Yeah.
So that means it's in ellipse.
And then the second one's a circle.
And then the second one is a circle because they're both 1 and 1. So I have an ellipse and I have a circle. So now I'm going to set these equal to each other because now I've solved for y squared. So I have negative x squared over 64 plus 1 equals negative x squared plus 64. So if I want to get x by itself, what are some thoughts? I have that weird fraction. What could I do to get rid of that fraction? I can multiply everything by 64. So this is where we're going to need our calculators. It ends up coming out really nice, but it's weird in the beginning. So 64s will cancel here. I'm left with negative x squared. 64 times 1 is 64. And I apply it to the left. So negative 64x squared. And then someone type in 64 squared. 4,096. Then I'm going to get all of the x's on one side and then all of the numbers. So I'm going to add 64x squared to each side. That gives me 63x squared. Then I want to move this 64 to the right. So what is 4,096 minus 64? 4,032. Now I want to take 4,032, divide by 63. And you get x squared equals 64. See, I told you it would turn out nice. Then I take the square root of 64, and what do you get? 8 plus or minus 8. So x equals a positive 8, and x equals a negative 8. So now I'm going to take that, and I'm going to plug in 8 and positive 8 into the original. I'm going to do the second one because the circle, that one looks easier. So 8 squared plus y squared equals 64.
Y is 0.
So y equals 0. And then for the second one, negative 8 squared plus y squared equals 64. So you end up getting 0 as well. So my two ordered pairs would be 8, 0, and negative 8, 0. Okay, we're going to stop here for today.